Hi AP, today we're going to do 2.7 ions and ionic compounds. Okay, so there's two types of ions. There are atoms that like to lose electrons and there's atoms that like to gain. Okay, so first of all, knowing the definition of ion is very key. So the definition of ion means charged atom. So atom with a charge. Okay, so if an atom or molecule, because we do know polyatomics, okay, if they lose electrons, they form a positive charge. So losing electrons, and they're called a cation. So usually with these symbols, you'd see a symbol with the positive and then however many that they lost. And if you have an atom or molecule that likes to gain electrons, it becomes a negatively charged, and you get what's called an anion. So you would get that negative charge on that symbol. And most polyatomics that we see from time to time, most polyatomics like to gain. There's only about two polyatomics I could think of, ammonium and hydronium, that actually have a positive type of charge. So in general, what happens is on the periodic table, you have metals that like to lose, and you have nonmetals that like to gain. And it has to do with those valence electrons. So if you take the example, our famous salt, okay, sodium has one valence electron, and chlorine, according to the periodic table, has 7 valence electrons. Okay, so when we put those dot structures around it, so what happens is sodium is missing just one electron to get to that complete octet, and sodium just happens to have one because he is nowhere even close to getting to 7 valence electrons. So sodium and chlorine do a little bit of a communication, and sodium will take that one valence electron he has, and he's going to give it to chlorine so that way it can fill chlorine's octet. So then you get sodium that lost its only valence electron, so it becomes sodium plus 1, and then chlorine gained that electron and now has 8 valence electrons, but because it gained an electron, it now has a charge of -1. But when we write formulas, compounds, we don't draw the dots. The dots are when we draw actual structures. So what happens is the name of the game for ionic compounds is you're trying to become what's called electrically neutral. And when you're electrically neutral, okay, it means your charges are canceled. Okay, they've canceled out, positive equals the negative, and it's 0. Then they come together. So then that's why we have our famous compound, ionic compound, sodium chloride. So in general, metals like to lose, and nonmetals like to gain. Okay, so there are some predictions of ionic ionic charges on the periodic table. So I'm going to bring up my periodic table real quick, and let's go ahead and label it. So on my periodic table, these are general charges, okay? So it's mostly the A groups. So everybody in group 1, because they're all metals except for hydrogen, they will always lose, oops, let me get my pen. They will lose 1 electron. So everybody in here will be +1, okay? So make sure you label the top of your periodic table. Now even hydrogen will. Now there is a purpose to why hydrogen is over here when he should be over here with the nonmetals, but he's over here with the metals. It's because 1, he has a valence electron. Only 1, just like lithium, sodium, and potassium, and everybody below him. He only has 1, and everybody in this whole group only has 1. No other group on the periodic table, besides the transitions can do some funny things, but no other A group has only 1 valence electron. So in the A groups, group number 2 can actually lose up to 2. I'm going to jump over here to boron's group. They can lose 3. Carbons can lose 4. And then as soon as you get to about here, then they start to gain. And they gain kind of like backwards. So nitrogen's group, they can actually gain up to 3. And then oxygen can gain 2. And the halogens, because they have 7 valence electrons, they're very close to getting that last electron, so they only gain 1. Now the noble gases are just perfect just the way that they are. So you're not going to see any type of charges on any noble gas. Now the D block, and we call the D block because of the orbitals, okay? These usually can have any charges. You can have 1s, 2s, 3s. I've seen manganese up to 7, sometimes 9. But they definitely will all lose electrons. So they will have positive charges, but they can have any amount of charges. But I do want you to label a couple of these transition metals because they don't have any other charges. Okay, so like silver is always +1 and zinc is always +2. Okay, so I always remember this trick, the staircase. If you go right here to silver, to zinc, to aluminum, you got the 1, 2, 3. Okay, so it's always a cool thing. Another trick that kind of stumps students too is you got to remember these charges up here gaining is because these are nonmetals. Remember I told you metals like to lose, nonmetals like to gain. So some of these elements down here under that staircase, they will lose, and they can lose other type of charges. Okay, so like for example, PB lead usually is +4. But he can also be +2, okay? So don't memorize. You can look at a formula to figure it out. So when I lecture on 2.8, I'll help you figure out what the charges are. But anybody under this staircase, they can also be just like the transitions. They can have other charges, okay? Like indium, he has like 3 different charges that I know of, and he could have more. He's usually +3, but sometimes he's +1 or +2. Same thing with tin, usually +4. But sometimes +2. So don't memorize them. Just be able to figure them out. Okay, so these are the general trends for the A groups. And then down here for the B groups, they can have many different charges. So make sure you label your periodic table with those common charges. Okay, so predicting those ionic compounds or those ionic charges, atoms or molecules can lose more than 1 electron, and it just depends on their position on the periodic table. So as we talked about ionic compounds, there's 2 types of compounds, ionic and molecular. So when we get to the next section, 2.8, it's going to start with ionic and then go into molecular. So ionic compounds, metals and nonmetals. You can even have metals and polyatomic. But the key is metals like to lose, nonmetals gain. Metals like to lose, polyatomics gain. Okay? And very rare, you can actually have a polyatomic bonding with a polyatomic. So one of these polyatomics would have to be positive and one would have to be negative. And do you see the trend? The very first one. When you write an ionic compound, the cation always has to go first. The positive goes first. And then the anion, whoever the anion may be, goes second. It's always the rule for ionic compounds. So ionic compounds is about losing and gaining electrons to get to that electrically neutral charge. And if it doesn't equal that electrically neutral charge, then you do a cool trick called the crisscross. So this very last example, as you see by here, you must combine cations and anions in some type of ratio to equal the total net charge. So let's say I had magnesium, okay, and I had nitrogen, okay. Now, you know you're not going to get any charges. You're going to have to look at the periodic table. So if you look at the periodic table, magnesium's right here in group 2, so he's +2, and nitrogen's over here in group 5A, and he has a charge of -3. So I'm going to put those charges. If magnesium had 2 valence, what if he lost 2? And nitrogen can go and gain 3. And you're like, well, wait a minute, he's only got 2, and this one wants to gain 3. How's that happen? Well, cool little trick, okay? If you crisscross the charge to make them like subscripts, okay? What happens is when you crisscross this 2, think of it as what's 3 times 2? Well, you get -6. And if you cross this 3, what do you get? 2 times 3, +6. And there's your electrically neutral, okay? So when you crisscross, you're crisscrossing the number, and then you're not crisscrossing the actual positive or negative, okay? So when that 3 comes over to magnesium, in this compound, if we actually drew it, you'd have to draw 3 magnesiums. And if we drew the nitrogen, you would have to draw 2 of them. Okay, so that would be the formula, ionic compound formula for magnesium with the nitrogen. Hopefully that helped, ladies and gentlemen. Make sure you label your periodic table with the charges, so that way it makes life a lot simpler when we practice. See you on the next one.